Hello once again. Thank you for joining us on Space Nuts, and great to have your company. I'm your host, Andrew Dunkley. And on today's program, we're going to be looking at how star-making galaxies cause galactic pollution on a massive scale. So it's not just people, it's the whole galaxy that does it. And a lot of galaxies apparently are very, very messy. They don't pick up after themselves. They leave socks on the floor. It's not a pretty place. And stars that are eating their own planets. And it's possible that as a consequence of this, the number of Earth-like planets out there might actually be less than we think. Plus some audience questions. David in Texas has got a black hole question. Surprise, surprise that people would ask black hole questions. And Martin in Wollongong is following up on something we spoke about recently, Asteroid 2021 PH27. With a few thoughts there. So we will get into all of that today on Space Nuts. And joining me, as always, is his good self, the Professor, Fred Watson. Hello, Fred.
Hi, Andrew. How are you doing?
I am well. How are you?
Very well, thank you. Survived the move okay and new surroundings?
Yes. You're in your brand new house, which is really old. It's still got suits of armour in the corridors and.
You know what the worst thing about it is, Andrew?
What's that?
About an old house. There's only one power outlet in each room.
Yes.
Yeah, so there's going to be
gosh.
There's going to be plug boards everywhere.
Well, the place we're in, which we built 7-8 years ago, has got more PowerPoints than you can poke a stick at. And of course, the big mistake you make is you try to figure it out on a paper plan as to where you want the PowerPoints and how you're going to lay your furniture out. And when you ultimately move in and put everything down, you go, could have put it on the opposite side of the room. Damn it. It's a bit wild and crazy sometimes, but glad you settled in. I love your view.
Oh, yes,
my goodness.
Very nice view out the window, yeah. It's that's what sold the place to us. We've got it's halfway up a hillside and we've got this lovely terrace. One day we might even be able to entertain you for dinner, Andrew, or something like that.
Oh, one day if we ever get out of lockdown. My word.
The view beyond it. It's very, very.
Yes, well, we've got near 500 cases in town now. So,
wow.
And very sadly this week we had our first death from COVID, which no one ever thought would happen here, but it did. So very, very sad indeed. Okay, let's get down to business. Where do you want to start? Well, we talk about how star making pollutes the cosmos, how galaxies are filthy, rotten little devils that make a big mess in the universe, the greater universe. I think this is disgusting.
Well, you're complaining to the right person, Andrew. That's if you've got a complaint, just put it in writing. We'll deal with it. In the world of astronomy, it's actually look. It's a story that, in many ways, is not surprising, but it is. It's nice to see it demonstrated. And the other nice thing about it is that this has got a very strong Australian component. The astronomers, one that is now, I think, based in Oxford, but they were part of the ARC Centre of Excellence for All-Sky Astrophysics in 3 dimensions. It's usually called Astro 3D, which is an Australian initiative. And so they have worked using telescopes on the on the mountaintop of Mauna Kea in Hawaii, which is without doubt the finest site for astronomy in the Northern Hemisphere. It's also a very sacred place to the native Hawaiian people, and that's an issue. But the observatories there do sterling work in terms of our understanding of space and the galaxy. They've used the Keck telescopes, or one of the Keck telescopes, which is on that mountaintop. And what they've done is they've looked at the way, first of all, how clouds of gas are pulled into galaxies, and then what comes out at the other end. I suppose that's the best way to describe it.
It's an intergalactic digestive system.
Well, that's exactly what it is. And, the gas...
And we all know what happens at the end of that process.
Yes, well, yes, you can draw whatever analogies you like on that.
Space doogies,
yes,
probably by the millions.
Yes, probably. So what happens is, as you know, the primordial universe, the universe before there were any stars, was mostly composed of hydrogen. and helium. They were the normal matter component. Of course, there's dark matter as well, which we don't know enough about. But the raw material for stars is hydrogen. That's the fuel that they burn, and when they are glowing and shining like our sun is, what's going on inside is the manufacture of other elements, like helium, like oxygen, carbon. All of these things are produced within stars. So, and then at the ends of their lives, the stars, they die in some way. And in a case of a star like the sun, it will have a long life, perhaps 10 to 12 billion years. And when it dies, it will be a fairly gentle process. It will shed its outer layers and the core will collapse into something called a white dwarf. But the bigger stars detonate. They basically go out in a much more spectacular way. They explode. There are a number of different mechanisms causing these supernovae, as we call them. But what the end product is first of all, much heavier elements are produced in the high temperatures of supernova explosions. And the other thing is, because it's an explosion with considerable power, these heavier elements are spread throughout the surrounding space. So they are, in a sense, polluting the space between the stars in that galaxy. Now, what then happens is, of course, new generations are formed. But some of that polluted gas, if I can put it that way, is basically blown back out into galactic space, the space between galaxies. Once again, because of the shock waves produced by supernova explosions. And that is essentially the mechanism that delivers the stuff back to the space between galaxies. So we've got one of the lead authors, Deanne Fisher, who's at Swinburne University here in Australia, makes a nice, quotes, the quote is very nicely put. On its way in, the gas is made of hydrogen and helium. By using a new piece of equipment called the Keck Cosmic Web Imager, we were able to confirm that stars made of this fresh gas eventually drive a huge amount of material back out of the system, mainly through supernovas. But this stuff is no longer nice and clean. It contains lots of other elements, including oxygen, carbon, and iron. And so, that's basically what happens. The expulsion of this gas, which is called an outflow, and people who study galaxies look at these outflows in great detail. That's delivering what we're calling polluted gas out into galactic space. But of course, it's because of that pollution that we are here, Andrew. Because it's those heavy elements that make planets and eventually living organisms. So we owe a lot to this form of intergalactic pollution.
It also contains traces of COVID, I believe.
Well, yes. There's all kinds of things going on in there that we don't understand.
You talk about this stuff getting blown out by supernovae into the cosmos, into that space between galaxies. On what kind of scale are we talking? We're talking, galaxy-sized clusters of
it's big. That's right. Stuff. So the outflows are sometimes many, many times bigger than the galaxy itself. Because basically they've been churning this stuff out for a long time, and so we're talking about hundreds of millions of light years generally in terms of what's going on. Wow. Certainly. So I beg your pardon. No, I'll do that calculation again. We're talking about tens of millions of light years, sometimes up to tens of millions of light years. So it's big stuff compared with a galaxy which might be 100,000 light years across.
And what would happen to that stuff once it's ejected and it's out there in the interstellar space?
Well, it's intergalactic space, the space between galaxies, which is very, very rarefied. And we know from other things that you and I have talked about, actually, that there's lots of electrons, of ions as well, which are atomic nuclei in that intergalactic space. So there is also some of this other material, but it will be very, very dilute. It'll be, it'll be almost undetectable because it's so dilute. It's only detectable as it's squirting out. When it gets spread out into galactic space, it's a lot harder to detect it.
It thins out and becomes just like a very minuscule oil slick.
Exactly. Yes, that's right. Or yes, pollution.
And this is generally caused by stars that die and go supernova.
Yeah. So the thing is driven by the explosions at the end of the lives of massive stars. Now, those massive stars don't last very long. Sometimes 10 million years or so, which is very short on the cosmic timescale. And so that's why you can make this, this balanced equation of stuff going in, being turned into stars and then into supernovae over a short timescale, and then being pushed out by the shock waves that drive these supernovae. It's a very nice piece of work, actually. It's
it is. It's
lovely stuff.
It is fascinating, and of course, the star we're all looking at the moment that is concerning. Well, maybe not concerning, but certainly interesting astronomers in terms of going supernova is Betelgeuse. Is that the one?
That's right. Yes, in the constellation of Orion, it's one that will eventually turn into a supernova. But whether it's tomorrow or in 10,000 years, we don't know.
Or it might have already happened and we haven't seen it yet.
Well, there's that too. Yes, it's about
because that's the really fascinating part of astronomy. We're always looking at history.
Yep. Something
could have happened, 100 years ago in our lifetimes or in our existence. And we won't see it for, who knows how long, because of the time it takes for the light of the event to travel. And I think I want to go back to our star. It's not big enough to go supernova, is it? Ours will go red giant and then, kill us all.
There'll be still a sticky end for anybody left on Earth at that time. And we're talking about this process will probably start in 2.5 billion years or something, and gradually build up to a crescendo in about 5 billion years. But I think, we might have, who knows what's going to happen to humankind? Will we just die off, or will we escape the solar system altogether and send the goo through space, as we discussed a couple of weeks ago?
Yes, exactly. Here's an interesting question. I keep thinking of questions. I don't know what's going on today. I'm acting like a journalist. Let's just say humans are still around when the process of our sun going, red giant starts to happen, and we have to leave the planet. And we have the capacity to move to Mars and live there. How much time would that buy us?
Yeah, probably on a human scale, it might buy us quite a lot of time. You might be talking about a few million years. But it's going to catch up with you eventually, because Mars is doomed as well. When the sun turns into a red giant. We do know that planets can survive that process, because there are certainly examples of planets in orbit around white dwarf stars, which are the final end product of this. Planets can survive without being completely melted, but it's not going to be good for any biospheres on those planets.
So if we time it right, we move to Mars, and then we move again, maybe out onto one of the moons of Jupiter or Saturn, and just, sit it out. And then when it shrinks back to white dwarf, we move to Mercury.
Maybe that's right. That's the trick. If you could do that, look, that's very good planning. Yes.
Oh, I'm a thinker.
You're a thinker, all right. You could be on the Intergalactic Council, Andrew. And,
you never know. And I can watch it all from the restaurant at the end of the universe.
Exactly.
All right. Some fascinating discovery in terms of how we junk up the cosmos just by being. Full stop. Yes, it's just the process that it just proves that a galaxy is just like a giant toilet system. What goes in and what comes out, just a big mess. This is Space Nuts. You're with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.